All right. Well, welcome everyone to an in-depth learning conversation, really, with OpenTEAM, the Open Technology Ecosystem for Agricultural Management. We're a project of Wolfsneck Center for Agriculture and the Environment. And our community is dynamic and growing and consists of over 45 different organizations and over 200 individuals who are active every month in various working groups and collaborathons and other meetings. So this series really is about building the knowledge base of the OpenTEAM community in a way that fosters coherence and collaboration. And each in-depth helps us to evaluate new concepts and technologies in order that we can ask better questions and build better tools together. So we seek to address common barriers rather than promote any specific solution. And in this pre-competitive space that we hold, we also bring together public and private partners to achieve better outcomes and accelerate innovation by sharing across boundaries. So today with us, we have Joel Paque. Is it Paque?
Paque.
Paque. And Conor Maguire with Impact Observatory. And they're going to tell us more about this new company that they've started in the last couple of years, I believe, which is meant to really empower decision makers with AI-derived land use information with cutting-edge spatial and temporal resolution. So I'm going to turn it over to Joel and Conor now, and so we can dive into a bit of their content, and then of course we'll open it up for some lively Q&A at the end. Thanks everyone for being here.
Great, thanks Laura. So I'll talk a little bit about Impact Observatory and who we are, and then Conor's going to talk about our global 2020 land use land cover map that we released earlier this summer. With our partners at Esri and Microsoft, and can talk a bit more about what other tools we're working on, and would love to just get some questions and get to know everyone. So let me share. Well, did they move the share screen on Zoom?
You should be able to. Bottom center should be a share screen button.
Oh, there we go. Sorry, looking right at it.
No problem.
Great. So Impact Observatory is just a little bit over a year old, and we're based nominally in Washington, D.C., but we have quite a few folks in New Mexico, where Conor is, as well as the Bay Area, New York, kind of all over as we grow in this interesting remote work COVID time. As Laura said, I kind of lead on partnerships. Conor is our principal product manager for that land use land cover. Happy to follow up with anyone if you want to get to us after. So we were formed a team that came together at the National Geographic Society to work on remote sensed issues there. And the founders really believe that we're in the midst of an environmental crisis, and that one of the many hurdles in solving our collective problems is better data for decision makers. And so our company was really founded on how can we help provide the data necessary to address climate change and biodiversity loss. There are superheroes in governments, NGOs, and industry. We work with all those sectors. So we have partnerships with the UN, with the World Bank, with some Fortune 100 companies, with some small NGOs doing really great work at a local level. So we're here to help whoever needs help. Some of the partners, as I mentioned, Esri and Microsoft, we'll talk more about them as we launched our map. We work supporting the UN development programs, UN Biodiversity Lab, which will have a launch next week. If you want to check out UN Biodiversity Lab, it is a global hub of 150 data layers drawn from places like academia, World Resources Institute, other UN and World Bank agencies with pretty much any data set you want to find about land use or biodiversity. The Gordon and Betty Moore Foundation have been really pivotal in some of this early work as well. Conor, why don't I let you take over from here? But I think the next slides are, yeah. If that's all right, I'll flip slides when you tell me.
Sure. Yeah, so what we built is a land use land cover map. So the idea behind this map is this interprets satellite imagery into land use and land cover categories so that you can have an understanding of what is actually happening on the ground. On the screen here is an actual example of our map overlaid on some other imagery, so you get some kind of more interesting colors coming through. You can see the categories that we provide in the lower left there. So we have 10 different categories that we break things up into that provide a number of different useful, ecological, and other applications. You hit the next slide for me, please. So not having global maps and the resolution of maps that are available can be a challenge. There are certain areas of the world, Australia, the US, that are really good for working with remote sensing data and make a lot of great data available. But there's other areas of the world that have less information available. This slide's talking a little about what's available in the States, which is one of the best places to look. Next slide, please. But globally, there have been much larger problems. So globally, you're looking at 100-meter resolution or worse, which is particularly difficult dependent for certain applications, smallholder ag being one of them. If you're trying to look at smallholder plantings, that's too coarse a resolution. There's also issues with how quickly things are produced. A lot of times there can be lags of years before the data is available, at which point it's interesting from a historical standpoint, but you're not going to make any actual changes to what's happening as it's happening with that. So that's one of the major things we focused on. We have a high resolution, 10-meter resolution across the globe using the Sentinel-2 from the European Space Agency, and we're able to do regular updates. We can push the map updates out within roughly a week of when the data was collected. So that's quickly enough that you can actually intervene to things that are happening on the ground. Next slide, please. So the way we approached this was by essentially labeling more data than has ever been labeled before. So we have over 5 billion pixels that were labeled. This has actually gone up since the initial collection and is still going up because the model's really only as good as the data that goes into it. And the way we did this, it was by what's called dense markup. So there are other approaches. A more common approach is where people will label a single pixel. And that is not super time efficient. It's a lot easier for you to label large regions together, and then the model can use all of those regions to train on. So that's the approach we took. Next slide, please. So we have our training and validation data sets sampled across globally and across different biomes. The way we chose this was to make sure that our model would perform well across the globe. So that's a major goal for us, was to have something that would perform well across all areas. They're information-rich areas as well as the information-poor ones. Next slide, please. So we used a UNet, which is a type of deep learning model, to actually build this. I can talk maybe a little more about that if people are interested. Next slide. Yeah, so how this actually works is as the model trains through the different epochs, you can see assuming this will restart again, the predictions get better and better as time goes on. So you can see the target there, and then as the time goes, the predictions start to look closer and closer to what that target actually looks like. So we used interactive training. It took the actual model that we went with, there was a lot of experimentation to get there, but the actual model took a couple weeks to train. on all the data we had. Next slide, please. Cool. So what you can see here is outputs for individual scenes. So as this progresses through, the scene on the left is the RGB, so the true color image from Sentinel. Our model uses more than just those 3 bands. It uses additional bands outside of the range of what's visible to the human eye. But those are the 3 that we're looking at here. And then in the middle, you're seeing what the model output was. So as what's on the ground changes, for instance, we just saw some snow. Snow came out here. When there's clouds, you'll see clouds. We generally filter for less cloudy images, but there are still some clouds in these images that get caught. And then what we do is we take all of those instantaneous predictions for the different dates across the year, and we create a most frequent prediction, but it's not literally most frequent. So for instance, in cloudy regions of the world, the most frequent thing you're going to see is clouds, which no one wants to see. So we obviously filter that out. And then there are certain classes that are more seasonal and more difficult to detect. So grassland, for instance, is usually not green all the time and often will appear as other classes in dry seasons. So we came up with a method for basically looking across the course of the year and determining which class we were going to select for the yearly map. Next slide. Cool, yeah, so this is what I was just describing, where we deployed the model over individual scenes and then composited those across time, and then we mosaiced them together into a global map. Yeah, and so this is freely available. So the 2020 land cover product is available on Esri Living Atlas and on Microsoft's Planetary Computer. They were our partners in producing this, and so you can get it there. We hit an overall accuracy of 86%. That varies across the different classes. Some of them are better and some of them are worse, depending on how hard they are to detect, really, and there's a lot of seasonality that can make that challenging. Just speaking to the model generally, it's really great for large-scale applications. It can be really good for smaller scale applications. But because this is a global model, it's not necessarily going to be the best performing thing for any one particular region. So if you only care about a particular region, there may be better data sets available or better models available that you could use. And you may see errors. The errors are not like 100% uniform. So it may be that if you're trying to look at a particular region, that might be one of the places we do less well, or it might be one of the places we do super well. I mean, you never know. It's always worth looking, but it's particularly good for, and is frankly the only source for some of the larger global applications.
Great, and before we go to questions, maybe I'll just talk a little bit about, so this, as Conor said, is out there on Living Atlas and Microsoft, free and available. We're continuing to refine that model, but also we're looking at, as we've talked to users and gotten some feedback, there's some things that we know we want to do, like further split out some of those classifications. So how do we create a model that breaks that 10 into some finer grades? We've also looked at some of the other sensors that are out there that have a higher resolution, some of the private sector sensors. So we're also looking at getting more classes as well as higher resolution. That's coming down the road. And we're also, because the model is run on Sentinel data, which goes back to 2017, we could provide the land use information for any of those years, for any point in time, for comparisons to see how land use has changed. So we're also looking at where people have use cases where that historical perspective is important to them, and where we can show them change over time. Other things we're working on that are a little further afield, but just to give you an idea of kind of where we're headed as you think about your own uses there. But I'd say over to questions or comments, or Laura, over to you.
Yeah. Thanks so much, Joel and Connor. We'd love just to open the floor now to some questions. I'm sure I have some too. But to start with, I see one from Forrest. Forrest, feel free to voice your question.
Sure. So I don't know a whole lot about artificial intelligence. I'm learning, but I have been exposed to Carl Friston's work with active inference, and it's being shared that it is much closer to the way that the human brain actually is able to deduce and make quality decisions. And it shortcuts the need of having to do a lot of training and works very well with live real-time data. So be curious about any comments if you're starting to use it, have any familiarity. I'm trying to just understand this myself.
Yeah, so it's not something that I'm personally super familiar with. We are in a stage now, so we pretty rapidly came up with our first product, and we did less experimentation with different learning methods and different model architectures than we want to do. So it's something that I'll take a look at and would be interesting for us to look at now, as we wanted to get something out somewhat quickly so that we could start engaging with different communities. And it's always better, so speaking as a product manager, to put something in front of people so they can tell you what's useful about it, what's not useful about it. It's a lot easier to get feedback from people that way and build something useful. We're now in a phase where we're trying to look at different architectures, different ways of improving the model as we add in different data sets. So that's something I appreciate you asking about that, and that's something I'll look into and see if that's something that could be useful for us.
Yeah, I'd be happy to try to help facilitate and accelerate that. I'll drop a few links in here, but also have a long-standing relationship with the folks behind it, which is being represented as the next generation of the internet using a new IEEE protocol, hyperspace transaction protocol, that's due to be released out into the public this coming spring with a whole set of tools. Anyway, so the other thing is I'm also working, I'm curious if you're familiar with the organization AI for Climate out of Mexico, Christopher Cordova. Anyway, they're doing a lot at the UN and other levels that have to do with biodiversity and many of the areas that you're discussing.
Yeah, Joel, do you know if we've had any chats with them?
We haven't. I'm a little familiar with them. I used to work in the climate policy space for a long time. So I'm familiar with them, but we don't currently talk to them, but it's a good reminder we should probably check in now. We've been pretty heads down getting this map out, and are now kind of emerging to go out and meet folks. So
great, perfect, awesome. Great work you're doing.
All right, thanks, Forrest. Other questions, Becca?
Yeah, I had a question. Thanks for the presentation. That was really interesting. One thing that we've encountered, sorry for the noise. One thing that we've encountered are just really large data gaps in areas of the world where you expect to see data gaps, but where the most need is. So if we're thinking about, the developing parts of the world, regions where we need to be focusing our efforts is where there isn't a lot of data. Have you all discovered some data sets that open that up, or could you speak to that?
Yeah, so that is totally the case we have found as well. So for instance, Sentinel-2, which is what we're working with right now, is an optical satellite, which means it's impacted by clouds, which means that there are a couple places, if you look around in the 2020 global map that we put out, where it will say clouds, which means every single observation all year long was cloudy. And so one of the things we're looking at right now is adding in a satellite called Sentinel-1, which is, it's a radar-based satellite, so synthetic aperture radar, that is going to not be impacted by clouds. So for certain applications, because it's not optical, it's a different kind of data you get back, which will be useful for some things and not as useful for others. For example, it's really great for identifying water. It's not as great if you want to look at the health of a plant compared to something like NDVI. Sorry, I gotta always try to keep my audience in mind. Using an optical satellite, you can actually look at more or less the color of the plant and determine how healthy the plant is. You can't do that with radar. So there's going to be some disadvantages to working with it as well. As we are also starting to push into other other sensors, we are looking at working with high resolution data, which won't help with some of those issues as much. But there are other satellite and other sensors up there that we think are going to be helpful. JEDI is one of them. It's up on I believe the space station right now, and can provide good information about canopy density and canopy height for forested areas. And then as time goes on, one of the things that we know we need to figure out is how we can work with regional data sets. So I don't want to say easy because that trivializes it, but it's a lot easier to work with something like Sentinel-2 that takes a regular observation every so often than it is to try to build a model where you're including data sets that or only exist for certain periods of time or for certain periods of the world. But if you don't figure that out, you're ignoring most of the data. And so that's a big area that we're trying to expand.
Thanks.
Locusag. I actually am a GIS analyst, so I know somewhat of what can track this a little bit more maybe than other people, but I'm curious how you guys standardize your data sets across use of different sensors. Like I would assume there's a difference in the background data quality if it's coming from a lot of different sources. I'm just curious, how do you guys account for that? And what are your techniques for standardizing your data sets?
Yeah, so we haven't had to deal with that yet because right now the labeled data has been on Sentinel-2 and the the data we're using for our model is on Sentinel-2. We are going to start working with other modalities and other sensors, working with Sentinel-1, for instance, being radar, because it's also from the European Space Agency, and we're not as concerned about issues of alignment and things like that as we're going to be with some of the other areas. We are looking at some other sensors as well, though, where that is a concern. So we have some remote sensing experts on staff if we need to. We know how to do things like co-register the data, so to fix alignment issues. So for those of us that aren't as aware of working with satellite data, one of the big issues is you have to, in order for the data to be useful using multiple sensors, you have to know exactly where it is on the Earth, which is a lot harder than you might think. These satellites are moving through space very quickly, and the alignment of them, very precise alignment, needs to be understood in order to know exactly where you're looking on the ground. Very, very small changes can mean large differences in exactly where you're looking. And if you're not looking where you think you are, then you're going to end up with basically bad data coming out of algorithms like ours, right? So if like roads will move between images and between sensors and things like that. So that's one of the challenges that you have to work with is how do you deal with these things? And another aspect of it is all of these sensors are designed to be slightly different. So if you compare, for instance, pictures from different types of cameras that can look a little different, even of the same subject. So it's a similar thing here. And so there are methods for dealing with that, but they're often computationally expensive and will slow down how quickly we can produce our model, which is something that's important to us. So far, we've been able to rely on the processing that has been done on Microsoft's Planetary Computer, who we've been partnering with for this. And we're hoping to, for as long as we can, to continue to rely on that. If necessary, we will start looking at processing the data ourselves. But like I said, it's difficult and computationally expensive. So we're going to try to avoid it unless it's absolutely necessary.
Great. Matthew, I see you have your hand up.
Thanks. So I must confess that I joined a little late and I missed your presentation, but I can go back and watch that. But I have a question for you, and just tell me, nope, you missed it. Just go back and watch if that's the case. But I'm curious, to what degree are you encoding your data sets or annotating your data sets with reusable ontologies about biodiversity? And so are you matching the labels that you're using to standardized terminologies that can be used in other operations? Thinking biodiversity ontologies, environment ontology, that kind of stuff.
So I got one comment first before I answer your actual question. One of the things that we're doing in addition to this project is we've worked with some existing data sets that use land cover as a major input. And we've been helping to work with the original producers to productionize those data sets so that they will be able to be produced more frequently and on a go-forward basis. And there is a biodiversity product that we have been working on for that purpose. So Joel could speak more to the specifics of that if you're interested. In terms of standardization, I'll be honest, not yet. Our categories that we have picked are pretty basic and are not defined specifically enough yet. There are different approaches to that. There's even a very exciting ISO standard on how you should define land cover categories that we need to look at. And so how our categories are defined is something we need to tighten up, and so that it can be used in ways you describe, as well as just making sure that it is really ironclad in terms of there's no question of what those categories mean. Whereas right now they're a little more fluid than they should be.
Yeah, and maybe I'll just use this to then talk about those dynamic science data sets Conor mentioned. So the three that we're currently working with are UNEP WCMC's Biomass Carbon Index, also UNEP WCMC and UK Natural History Museum's Biodiversity and Taxonomy Indicator, and World Conservation Society's Human Footprint Index. So in the case of all three of those, I think Human Footprint, there's 3 years they've put out, the most recent being 2017. BII, I think there was 2015 and 2019. And Biomass Carbon, I think, was also 2017. So we're working to build those models on top of our land use land cover annually. So you can see annual change over time instead of waiting 5 years for that data to update. And to your question about the terminology we're using, in that case, we're following those institutions' leads, right? We are not the biodiversity scientists and experts. We're not going out and trying to write our own classifications. We're just providing the underlying differences in land use land cover. We've also been talking to one potential project in California where it's a U.S. state, so they follow USGS land use classifications and use that terminology, that hierarchy. So we said, okay, we can like Conor said, ours is currently generic, but if we need to fine tune it to something closer to USGS for this, specific US government application, like that can be done as well. So we didn't want to pick one standard and say, okay, we're going to go with USGS entomology and do that globally because other countries have different classifications they use. So we're trying to be open source in that way, and flexible enough to just understand the differences in the classifications and worry about the terminology based on the needs of the user, if that makes sense.
Yeah, I think so. Certainly would be interested to speak with you all more about that. Thanks for the link to the ISO standard in the chat. And to what degree do you think that you're developing a new product? Do you see yourselves, or you have a new product, do you see yourselves sort of wanting, maybe not wanting is the right word, but how do you see the industry of what you're involved in evolving around you as new data sets and products like this come to light? Like, what do you think your competitors will be like, and what does that landscape look like to you as you look into the future, the brave new world?
As a relatively young company, that's a question we ask ourselves all the time, in an emerging field nonetheless. I think for us, this 2020 map is free. It is out there for all to use. And the impact part of our name of Impact Observatory is something that we take pretty seriously. And so we really believe in the democratization of data. And we want to, as I said in my intro, get the best data to the decision makers who are working on the thorniest problems and issues. That said, we are a company. We are here to also build our company and not run on a solely philanthropic model. So what I think is, as you see more of these geospatial intelligence companies emerge and where this field is going, is that for the past decade or so, all those sensors that Conor was talking about have grown exponentially, right? The amount of cameras in space collecting data is pretty crazy, but the data is not really useful, right, in its form of just imagery. And so now there's a lot of work, especially in this AI field, of okay, when you have just massive petabytes of data, how can you quickly get to the information that's going to solve somebody's problem? And the problems that we're interested in, like I said, are climate, biodiversity loss, human impacts on Earth. In the public good side, in that impact side, it's okay, how do we work with the NGOs that are out there working on conservation projects, working with farmers to introduce regenerative ag practices, right? What is the data that people who are earnestly committed to behavior change, what data do they need to improve those practices? Then on the corporate side, where I think this is going is, as we've seen the evolution from CSR reporting, that a decade ago you had to kind of have a corporate social responsibility plan that you would publish. And then a few years after that, you actually had to appoint somebody for that to be their job. But it's gotten more and more serious. And as we kind of transition to this world where people talk less about CSR, more about ESG, right, environmental and social and governance investments, you have major industry players out there, major financial institutions who are taking those commitments more seriously and know that they are going to be held accountable. So they are also interested in this data, right? They want to know how their operations and their supply chains are impacting natural resources. And the most forward-thinking ones are thinking about how will climate change those supply chains? So how can we have the most up-to-date data to make the best decisions possible? And so, in the presentation where Conor outlined one of the kind of general challenges in this remote sense information is especially if you're talking about a global data set, you might not get an update for a few years. And sorry, I forgot who asked the question earlier about, places in the global south, especially, it might be 8 or 9 years before you get really good data that's useful for any kind of analysis. And so I think that where machine learning and AI is really going to change things is just getting more actionable information on a much shorter time frame, right? You're talking about potentially a week turnaround to see real world confirmed change on the ground to understand what's happening. Does that answer your question? It's kind of my philosophical.
Yeah. No, I thought that was great. If I could just sort of follow that up with one more, is that all right? Am I stepping on anybody's toes here? I'm looking at your face, Laura, to see if you're.
Yeah, none so far. If anyone wants to raise their hand or give an indication.
Yeah, well, okay, I'm just going to follow up then, since nobody else has raised their hand. I just thought I would mention that well, we would love to talk to you more. And when I say we, I mean both IC Foods as well as a new NSF AI Institute that I'm part of called icicle.ai that's being led out of Ohio State. And in fact, I wasn't going to do this sort of self-plug thing, but you mentioned reconfigurable supply chains as a result of climate impact. And that's one of our driving use cases at icicle.ai. So I would encourage you to think about, this is a newly funded NSF AI Institute. I would encourage you to think about what kinds of federally supported infrastructure would help you deliver what you want to deliver that would be reusable for other people in this emerging industry that you see, and ways that we might work together. We can certainly follow that up offline.
Great, would love to have that conversation.
Great.
Thanks, Matthew. Pablo, you have your hand raised.
Yes, thanks so much for the presentation. My question would be, so if we wanted to have, now that you mentioned regenerative practices, if we wanted to have like a global map of where regenerative practices are happening or what regenerative farming and ranching is happening, would this be a layer that we could build upon the map that you have created? Or do you have anything going on in that regard already?
So, do you want to take that one, Joel?
Yeah, I was gonna, why don't you give a quick answer? I'm gonna pull up Navigator just to show, yeah.
Sure. Yeah, so as of right now, our product would likely be a useful input, but probably would, I mean, not probably, does not give you all the information you would need in order to build something like that. So one of the classes we have is a crop class. And so you could look at our product to establish where crops are in a region. As time goes on, we are planning on building additional subcategories. So something we have planned for the somewhat short term for our crop class, for instance, is breaking it into paddy crop and non-paddy crops, or rice paddies. And for instance, I'm aware that we could see, I'm not an expert in agriculture, but I'm aware of at least some work in the rice paddy space to, I believe, not keep the field flooded all the time to reduce impacts. And so that would be something we could probably observe and could eventually build into our categories. But we haven't done that yet. And so one of the things we are interested in is having conversations with people about what would be helpful to add. So we're trying to work, I mean, that's why we're having conversations like this, is so that people can tell us what's useful about what we've built and also ask about additional things we could add, because we want this to be helpful to everybody. And so it's an area that we're interested in supporting, either by adding things directly ourselves if it's something we're capable of doing, or by having our product be an input into mapping and algorithms that other people produce.
Yeah, and so another tool that we've that we've built is called Navigator. So I mentioned the UN Biodiversity Lab platform that'll launch. It's actually in 2 weeks. It's quietly launched now if you were to Google it, but it'll have a full public launch soon. So we helped UNDP build this, but we also have our own deployment of it. Oh, let me share again. I'm talking to screens you can't see. So what you see now, this is our land use land cover pulled up globally. But we have, as I mentioned, there's about 150 different data sets that are all free and publicly available that come from places. This is World Resources Institute's aqueduct data is on here. We have Global Forest Watch. This is the Biodiversity and Intactness Index I mentioned earlier. So any of these can be toggled on and off globally. If you zoom into a particular location, we'll go to Costa Rica. What you see here on the left is for the 8 of those 150 data layers that UNDP said are kind of the most used. We've pre-calculated all the metrics for any area of interest. So what you see on the left is this top one is Global Forest Watch's annual tree loss for Costa Rica. For any of this data, if you hit the little info, you get a brief description of what it is, a link to the peer-reviewed paper, downloading the actual source data. That's right on there. You also, if you only care about Costa Rica and you don't want the whole global data set, you can download for just your area of interest here to analyze in Excel or wherever you want to take that data to look at, clipped out just for your area of interest. You also can upload your own area of interest. So if you actually care about just a farm or a collection of farms, you can create an AOI and get these same metrics for all those 150 data layers just for the places that you care about. But to your particular question about can you overlay regenerative ag over global ag, if someone had, as Conor said, there might be a way to remotely sense good regenerative practices, or if somebody had that data where they knew there were certain farms that were using best management practices, and you just wanted to understand what else is happening on or around those particular farms, this Navigator makes it really easy to see, oops, sorry, trying to talk and click, to see 2 data sets overlaid. So if we take off our land cover, let's put forest loss on, that's one data layer. And then if we put on, this is the world database on protected areas. So both are on there, and we can change the opacity on WDPA. Oops. So what you see here, this is the border of Costa Rica and Nicaragua. In Costa Rica, you see very little forest loss and almost none in protected areas. And if I zoom out a little bit, you can see for Nicaragua, you have a ton of forest loss in an ostensibly protected area. So you don't, what I'm trying to show is if you had a data layer that was regen practices, Navigator makes it easy to put that on, put up that land use land cover type. We have NDVI if you want to see, crop health and vegetation, or the biomass carbon would be one that would be interesting to see laid over regen practices. Navigator is an easy way without having to do kind of any extensive GIS analysis to just quickly go to a spot you care about and know, take 2 data layers that you care about and stack them and see how they compare.
Fantastic. Pablo, do you have any last questions?
Yeah, my other question would be quickly related to that. So we have, I was thinking on an application we have, we're doing like digital storytelling about farmers, and it's consumer facing, and we're currently using Google Maps. Just every farm, every story has a location. Every story we're telling you where this is happening. So is this a resource that we could use instead, because this has much richer information regarding life indicators instead of just geographical. So is this something we could use like in a mobile application as the location for farms and food production?
I'd certainly be happy to talk to you about how we can. Yeah, right now our only we like I said, we've been focused on this big UN global site, but you know, we, like I said, as a young company, we've built some cool things and we're trying to figure out how people want to use them. So Paulo, I'd love to chat about that.
Okay, thank you.
Thanks, Pablo. And I'll just note, Jeff too had a comment with regard to just I think the complexity that exists when we talk about regenerative practices and yeah, we can come back to that. I know that Becca had her hand raised. If you had a question, Becca, and then Jeff, if you have some other additional questions or comments, we can maybe move to you.
Yeah, thanks. That was really cool to see. Thanks for sharing that. We find a lot of limitations with just the soil depth of what you can see using satellites, and that's really not reflecting a lot of the changes and impact that practices have. What do you have to say about it? It's certainly in our, in our room, and we're talking to producers, and they're, they know that a lot's happening below 10, 15 centimeters.
Yeah, I'll let Conor answer about what sensors can understand how far into the soil. But I would say we get this question a lot when we talk about biomass carbon. So I mentioned we work with UNEP WCMC's biomass carbon index, which is based on, averages for biome type that someone, I forget who, has taken from core samples around the world. So we're not the ones who are going to say this is the way to measure biomass carbon. We work with UNEP WCMC because they're a very vetted institution. If someone else had a different biomass carbon index and said, can we use your land use land cover as an input to it? That's great. We're not here to be the arbiters of whose model is best. There's a lot of biogeochemical models that people are building out there. We're just interested in providing better underlying data where it's useful. But Conor, do you have any thoughts on if there's any current or coming sensors that have a better depth ability to understand changes at depth below surface? Or is that just too far afield?
There's nothing I'm aware of. Doesn't mean there isn't anything coming. I guess what I would say generally is there's a lot of applications that, so we have a hammer, basically. We're building a global map using remotely sensed data at this point. We may move past that to other types of data sets if we find things that are useful. But it's going to be good for some stuff and not good for other things. So it's, we're happy to help where we can and provide light on certain things. But it's, yeah, you can't solve everything with what we have, for sure.
Thanks for trying.
Exactly.
Jeff.
Just to follow up, and thank you, Conor, I really appreciate your nuanced responses to these things. And this is maybe the first time in an OpenTEAM call I would go a little further than you did and say, not only can you use your product for some applications, but not others, but there are probably a lot of applications where you can use your product as a starting point for a conversation. And so I think Pablo's question was really good, and he's coming from a fascinating space where he's actually creating stories that are very local. And the cool thing about creating a local story is that you can make it very specific. And so you can actually talk about the relationship between those regenerative practices and the sustainable potential of that specific piece of land. Mm-hmm. Its slope, its aspect, the soil depth, the history, as Rebecca was saying. So you can actually, you're able to do that because you're telling a story. Now, when we tell stories, it helps a lot if we can start with all the available information. So we're not like just standing out in the middle of the field and saying, well, I don't know, even if that information isn't at the right scale, even if it's not as precise or accurate, or both, as we'd like it to be. So I think as Conor and Joel, as you guys continue to think about your product, again, I'm just ecstatic to hear a couple of people talk realistically about their product as opposed to just trying to pitch it as everything for everybody. And I think for that reason, for no other, and the fact that you've actually developed what seems to be a really interesting approach, I think you've got a lot of potential to serve in that third role as a starting point. So thank you.
Thanks, Jeff. I might ask a question or two, or just thinking about this audience here. I know we have some kind of hub farm level representation and some tech representation, and yeah, just from across our community. And Joel, when you were saying like the thorniest issues for those people on the ground and wanting to support them, I'm going to put my farmer hat on and say that maybe they get to deal with the thorniest, thistle literally in their pasture. And so I guess there's two questions. One is around data privacy. What types of conversations or concerns you've had come up around private property and all the data that you have on it. And secondly, around, how you consider farmers and ranchers as your audience. Is that a primary, secondary audience? And when it comes to like, 1 week or 1 day, there can be a lot of support and change that happens on a farm. So are there opportunities for your maps to support that, or would it be more so just kind of higher level than that?
Data privacy, I don't think it's come up too much, except one interesting conversation I had where was talking to an individual who works with a lot of IPLC communities outside of the US. And I said, does this have any usefulness for, land tenure issues for IPLC?
Sorry, what's an IPLC?
Indigenous populations and local communities. And so there's there's a very strong case that for lands where IPLCs have stronger land tenure and more ownership rights and management, they are better managed lands. And so I was asking, hey, can this be helpful in solving some of these issues? Can we better delineate, help you establish land tenure and rights? And they said, actually, some of the groups wouldn't want to have necessarily better delineated land. So I said, look, we can find really small human settlements deep in the Amazon. And she said, some of these are chosen uncontacted tribes or limited contact tribes. And they don't want potential loggers or big ag to have better information about their lands, which was an interesting perspective. Whereas we were coming at from the democratization of data, we want it out there. There are some valid reasons others don't. So I can't say we've had many more issues like that run into, and that was a much more a hypothetical, but it was a good reminder that there are other perspectives on this issue out there. To the second part about farmers, this is one back to Conor's previous answer. We have a big global hammer. And if you're a farmer worried about your specific property and that rapid change you mentioned, Laura, I don't know that we have a lot of good solutions. We could tell you land use change every 9 days when the Sentinel satellite flies over. You probably know what's changed on your farm faster than every 9 days. But if you want to understand where some of those other data layers, where you measure on one of those other indices, that's where we could be helpful. So if you have want to understand biomass carbon and you like one of the biogeochemical models that we host on our Navigator platform, then we can give you that information for your farm at 10-meter resolution. But that's probably not the weekly what's happening on my property change that's going to impact you. It's more the probably at the annual, how am I approaching this next season of planting and what practices I want to do based on the returns I'm seeing from last year. Does that make sense?
Yeah, definitely. And I'd love to ask one last question. We're running up on to the hour. Is I mean, how can we support you as an OpenTEAM community?
That's a great question. I mean, I think I love all the questions and feedback we got, and love people chatting me to say, hey, let's follow up. So would love to keep those conversations going. Matthew, Pablo, whoever else wants to hear more. I know Conor has been joining some of the tech working group calls. So we'd love to just continue to learn more about OpenTEAM and love to attend some of these webinars from other members of the community. And like I said, we take the impact side of our name seriously. And so we were impressed, Laura, when we first met about the quality of the community you've built and the goals you're trying to hit. So we would just like to keep understanding better who in the community could use this type of land use information and find some partnerships. So.
Yeah, and I think we could all stay for another hour to talk specifically on that front. Just thinking of the use cases we have coming up. Bless you, Conor. And I think Pablo, questions about kind of data-driven storytelling. I think we could definitely follow up on that. I think you've sparked my curiosity as it relates to our ag data wallet and how we could kind of underlay some of this mapping as part of that. I have more questions about how you work with markets and supply chains and how we could work together on that. So I think it's just the beginning. But I want to thank everyone for joining. And Conor popped in their emails. And Joel, Conor, let's catch up soon.
Case that I have just been thinking on over and over again throughout this conversation.
Oh, whoops.
Oops. Sorry, can you hear me?
Yeah, we can hear you.
As we do land use assessments for creating field boundaries, oftentimes where we see flooded areas or areas that maybe the land use has changed over time, I think that what you have presented may be a really useful tool for providing automated classification models. So I think that's another use case that I definitely would be interested in following up and exploring more with you guys as well. So I'll send my email as well.
Great. And Laura, I know we're at 1 minute over, but on the data-driven storytelling, one of my favorite examples of that is we had a call with a group doing some pretty awesome, ambitious conservation across the whole state of Florida. And so we were really meeting with the science team. But the executive director joined, who's not a scientist by background, who's kind of their chief, cheerleader and lobbyist at the State House. And so we did our whole whiz-bang tech AI presentation. And he was like, man, I just want those maps because I can take those into the State House and get you money. Like, I just need pretty maps. And it was a good reminder that we want to give people the best information to make decisions. But sometimes people are just compelled by a really pretty map of a place that they love. So yeah.
Yeah, I like that. I like that. All right. Thanks, everyone. We'll see you next time.
Thank you.
Thank you.
Cheers.